Here's a nice problem. Let A consist of all numbers made up using the prime factors 2, 3, and 5. Consider the sum of all reciprocals of numbers in A. And we want to find the sum. We want to find out what this sum is. Well, the first thing is, let's write down the sum. You have 1 over 1 because 1 is, for example, 2 to the 0. You're allowed to have factors of 2. 1 over 2, 2 is in A because 2 is 2 to the 1. 3 is in A because 3 is 3 to the 1. 4 is in A because 4 is 2 squared. 5 is in A because 5 is 5 to the 1. 6 is in A because 2 times 3 is 6. 7 is not in A because you can't use the prime factors, 2, 3, and 5 to generate 7. But 1 over 8 is certainly allowed because 8 is 2 cubed. 1 over 9 is allowed because 9 is 3 squared. 1 over 10, or 10 is allowed because it's 2 times 5. 11 is not allowed, but 12 is. 12 is 4 times 3, or 2 squared times 3. 13 is not allowed. 14 is not allowed because they use the 7. 15 is allowed because 15 is 3 times 5. 16 is allowed because it's 2 to the 4th. 17 is not allowed. 18 is not allowed. Well, 18 is allowed, excuse me. That's 9 times 2, or 3 squared times 2. 19 is not allowed, but 20 is because it's 2 squared, 4 times 5. And you keep going. The question is, find the sum. What is that sum equal? Now, I maintain that this is a pretty simple problem because if you just consider 1 over 2 to the 0, actually let me write that. If you consider 1 over 2 to the 0 plus 1 over 2 to the 1 plus 1 over 2 squared, etc., times 1 over 3 to the 0 plus 1 over 3 squared plus 1 over 3 to the 1, plus 1 over 3 squared plus 1 over 3 cubed, etc., times 1 over 5 to the 0 plus 1 over 5 to the 1 plus 1 over 5 squared, etc. I claim that every number in this product in the bottom is here, and vice versa. That is, those are the same. For example, if you want to get 1 over 4, well, you have to multiply something from the first bracket by something from the second bracket times something from the third bracket. Well, 1/4 times 1 times 1 is 1/4. If you want to get 1 over 20, you can use 1/4 times 1/5, that's 120, times 1. Every sum that's in the red will be obtained from multiplying those three in the bottom. The bottom won't have any extra stuff because if you take something from here, say 1 over 2 to the A, and you take something from here, say it'll be in the form of 1 over 3 to the B, and you take something from here, it's going to be 1 over 5 to the C, and you multiplied these, well, you're going to get something in the form of 1 over 2 to the A, 3 to the B, 5 to the C. But every number of this form is here. Every number of this form is here. And every number up here, say this number, this is 1 over 2 to the 0, 3 to the 1, 5 to the 1. Well, I can multiply 1 over 2 to the 0 by 1 over 3 to the 1 times 1 over 5 to the 1, because it's going to be there. These two are equal. Okay? But now the nice part is that although I didn't know there's some in the top, I know what this sum is. Since it starts with 1, it's 1 over 1 minus a half. And I know what this sum is. Times, since it starts with 1, it's 1 over 1 minus a third. And I know what this sum is. It's 1, since it starts with 1, it's 1 over 1 minus a fifth. And this is pretty simple to compute. In the first bracket, if I multiply everything by 2, I'll get 2 over 1. Because 1 times 2 is 2, take away 1, you get 1. Times, here, I'll multiply every term by 3. The top will be 3, and you have 3 minus 1, or 2. And the 2's will cancel. And then you have the last one. I'll multiply everything by 5. So you get 5 over 5 minus 1, or 4. And it seems to me that this answer is just going to be 15 over 4. So we have the answer. It's 15 over 4. The nice part about this is if you look in the middle and that I'm highlighting in blue, you don't really see a pattern. For example, out of nowhere, we skipped 1 over 7, we skipped 1 over 11, 1 over 13, 1 over 14, 1 over 17, 1 over 19. Couldn't seem more random. Yet, we can still figure out the sum fairly easily. Now, I'll show you how, if there's just two factors, why what I'm saying is working. That is, well, too much writing here. You'll see what I mean in a moment. So if you have 2 to the A times 3 to the B, if these are going to be the denominators, okay, so what we want to do is add up all possibilities. First, we'll start with 3 to the 0. And we'll go over, we'll let A change. That is, you have 1 over 2 to the 0 times 3 to the 0. Plus 1 over 2 to the 1, 3 to the 0. Plus 1 over 2 squared times 3 to the 0. Etc. Well, this is going to equal to 1 over 3 to the 0, the common factor, times 1 over 2 to the 0, plus 1 over 2 to the 1, forever and ever. Now, let B be 1. So you have 1 over 2 to the 0, times 3 to the 1, plus 1 over 2 to the 1, 3 to the 1, plus 1 over 2 squared, 3 to the 1, etc. Well, here, I can factor out 1 over 3 to the 1. And I'll have this in the parentheses. Now I'll let B be 2. So you have 1 over 2 to the 0, 3 squared, plus 1 over 2 to the 1, 3 squared, plus 1 over 2 squared times 3 squared, etc. That is, I can factor out 1 over 3 squared. So I have 1 over 3 squared times this stuff. And I keep doing this forever. Okay, which means that I'm going to be multiplying this, I'm going to be multiplying this, each denominator. So I have every power of 2 here. Non-negative power. 2 to the 0, 2 to the 1, 2 to the 2. And then I'm supposed to be multiplying them by every power of 3. But I am. Here, I'm multiplying each bottom by 3 to the 0, and then 3 to the 1, and then 3 to the 2, forever and ever. Now, if I were to add up the right side, if I were to add up all of these, well, what's common is 1 over 2 to the 0 plus 1 over 2 to the 1 plus 1 over 2 squared, etc. times, well, here I'm multiplying this by 1 over 3 to the 0 plus here I'm multiplying what I factored out by 1 over 3 to the 1, and over here what I factored out I'm multiplying by 1 over 3 squared, etc., etc. But that's what I said in the previous page. Wish I had a little bit more room on the right, but I'll put it here. I would have 1 over 5 to the 0 plus 1 over 5 to the 1, etc. And the reason I dotted the brackets is what's in blue shouldn't really be there because I'm only dealing with 2 factors. But it carries on because what happens here is this product gives me every fraction possible that has a denominator with with bases of 2 and 3. Every one. So now what I need to do is multiply this by 1 over 5 to the 0, and then multiply it by 1 over 5 to the 1, and then multiply it by 1 over 5 squared, and then multiply it by 1 over 5 cubed, and add that result up. But that's just going to give me what I said a moment ago. It will be 1 over 5 to the 0 plus 1 over 5 to the 1, etc. So this problem looks very complicated. It looks very, very complicated. But once you realize, let me erase this. Once you realize that it's nothing more than 1 over 2 to the 0 plus 1 over 2 to the 1 plus 1 over 2 squared and so on times 1 over 3 to the 0 plus 1 over 3 to the 1, etc. times 1 over 5 to the 0 plus 1 over 5 to the 1 plus 1 over 5, 2, etc. And each of these were geometric series. It became easy. It became very easy. Okay, if you like math like this, subscribe to my channel, or leave comments below, and most of all, have a great day.